What is up, mathletes? So let's get into normal distributions. I have a video, but I want to walk you through homework. And now with AI and all this things that are keep moving and developing, I want to remind you of the tools that you have. So don't just do the homework. Know what is it that you're looking for, and when you're doing these applications, what can they help you find so that you could take this knowledge and use it for something else. All right. So one thing that I have here, we're going to be looking at section 7.2 for those of you that are my students. And if you're not my student, again, we're just looking at normal distributions. So check this out. I'm just messing with some ChatGPT stuff, typing a bunch of things just to show you what you could do whenever you get stuck on anything. So when we have a normal distribution, think of, here's a good example of basketball players, right? And I'm going to look at heights. I know that they're talking about points per game, but think of basketball players and heights. What you're going to see is most of the basketball players are around a certain range. Say we're talking about NBA. Maybe they're 6'3", 6'4", 6'5". Say the majority of them, right? When we get everybody's heights is say 6'2" to 6'6", right? The majority of these players. But you do have some that are on the extremely tall side, right? That are in their 7'3s and 7'2s and whatnot. And then you might have some, very few, that are on the other end for a basketball player that might be considered really short, maybe 5'11, 5'10. I think what Steph Curry right now, was he at 6 or 6'1"? I think one of those two. So he would be on the shorter end compared to the average. So when we're looking at normal distributions, we're going to get this bell-shaped curve. So let's jump into some applications, and I want to talk about two things here. So number one, there's these cool features, but I want to make sure you're not making these common mistakes that a lot of people make. All right, so let's set the scene, and let me help you make sense of this, because I don't want you just copying down answers. I want it to make sense to you. All right, so you got a normal population. So what that means is we're going to have a bell-shaped curve. I'll show you the drawing right now. And right smack in the middle, the mean, mu, is 9, and your jumps are going to be 5. All right, your standard deviation. So each jump is going to be 5 units away from 9. And the first question says, hey, what's the proportion? What's the probability? What's the area, right? All those words we talked about are the same. So what's the proportion of the population that's less than 19? All right, so this is how we handle this, mathletes. All right. So again, I'm going to talk about what's good about this and things to be careful of. So make sure you have your calculator ready. I'm going to show my calculator and kind of give you a heads up of where I want you to be careful. So the first things first, right smack in the middle. So draw your normal curve. So this is like a bell-shaped curve, right? It looks like a bell. So draw that curve. And right smack in the middle, you're going to draw the mean, which is 9. So 50% of our data is going to be to the left. So 50% of the population is to the left of 9, 50% is to the right. All right. And this question says, what proportion is less than 19? So what we do is we draw a line right here at 19 and you shade. So I always want you to draw, and even if you're not in my class, this is a great technique, is you draw your bell-shaped curve when you have a normal distribution, and it's less than. So less than, that means you shade to the left. So make sure you got that down. All right. So because this is a normal distribution, we're going to use this program called Normal CDF that is in your calculator, maybe your TI-84 Plus, maybe you're using a free app like the one I'm going to load. And there's a bunch of resources out there. All right. So the way you get there, you go to second vars to access the distribution menu, and then we're going to choose normal CDF. So I'm going to do that with you. All right, so let me share my calculator, and here we go. This is going to load up in a second. So I'm going to hit second vars, and I'm going to go to normal CDF. So the first thing I do is I enter the lower bound. So because I'm going to the left, let me show you what I'm talking about. Let me go back to my picture. So because it says I'm shading everything to the left, the lower bound, this is the way I want you to think about it. Where do I start shading? So I start shading from the left-hand side. And so what I'm going to use, and what the program tells you to use, and the shortcut here is I'm going to use -1 E99. So what this means is you're making sure this number that I use, I start shading way the heck over here to the left. And I'm making sure nothing's neglected here. So it's just a big negative number if you want to think about it that way. It's a really negative number. So like -10,000, -20,000, -1 million, right? We're making sure it's massive negative number. All right. So that's why you're going to think about it. And then your right endpoint is going to be, where do I stop shading? And so I'm going to stop shading at 19. All right, so there's two things to be aware of. Let's go back to our calculator. So I got normal CDF. Make sure you use this negative sign, because if you use a minus, it shouldn't matter, but the way the program set up on these calculators is it will matter. It'll give you an error. So we hit -1, and then I'm going to hit second. And again, this is where I see a lot of mistakes. Make sure you use the E button, because there's another E button that students are using that's giving them an error. So make sure it's the one where the comma is. All right. So again, I hit second EE. I'm going to hit 99. All right, comma, and then I stop shading at 19. Right. All right. The third number that you're going to punch in is the mean, is mu. And in this case, the mean was 9. And the last number, the fourth number you punch in, is the standard deviation, which in this situation was 5. A lot of you guys are going to have a nice program, and it's going to tell you in words, lower bound, upper bound, mean, and standard deviation. So it's going to be a nice template. This is kind of like an old school format, but it's the same idea. So there's our probability. So the probability that the value would be less than 19 is 0.9772. And we're going to round that to 4 decimal places. So if I go back to our problem here, right, notice they punched in the same thing we did, and they got the same answer we did. All right. So the key is going to be to make sure that we understand what is it that we're entering into our program. And when you get into these word problems, it's the same thing, but you want to make sure that you draw your distribution just like we're doing here. All right, let's look at part B. What is the probability that a randomly chosen value will be greater than 4? All right, so notice, once again, we draw our normal curve. So you make sure you draw that. And then right smack in the middle is our mean, right? And then 4 is over here. And so what we're doing is we're shading now. It says greater than 4. So that's why you see it shaded to the right. All right. Some of you may not even need, I'm just scrolling down here. You might think, oh, can't we just use the empirical rule? Well, there's reasons why, some situations why we won't be able to. We'll get into all that. In some very few instances, we will be able to use empirical rule, but here's the fastest way to do it. Just use this program, normal CDF. So we use normal CDF. If you're in my class, we talked about it. When they ask us for an area, when they ask us for a probability, when they ask us for a proportion. And again, our distribution has to be normal. All right, they're going to tell you that somewhere, or it's going to be implied. All right, so again, we're going to punch this into our calculator. So I'm going to do this with you. All right, so notice here, my lower bound is going to be 4, but because I'm shading everything to the right, my upper bound is going to be 1E99. So let's go to our calculator and let's do that. So we're going to go to second vars, normal CDF. Oh, it looks like a commercial's coming up. Let me find the X. I don't think I want to buy this today. All right, so we got normal CDF. Our lower bound we said is 4. Our upper bound is a 1 second E 99. So remember, it's that EE. So make sure you use this comma one, or else you're going to get an error. I see it all the time. And then our mean we said is 9 with our standard deviation of, I believe we said 5. All right, so we punch that bad boy in. There it is, 0.8413. So if I go back to the answer key right there, that's exactly what they're doing. So again, I want to do this because a lot of people are using these buttons, but they're just copying everything and they have no idea what they're doing. So I want to help there. All right, let's jump to another question here. All right, so sorry for all the background noise. My son's having he's barbecued pulled pork sale today, and he's been up since 3 smoking that sucker, and it's noisy in the background. He has like 50 something orders. So, but smells delicious. All right, so we got normal distribution. So we got, again, a standard normal curve, or not a standard normal. We got a normal curve with the standard deviation of 9. The mean is 55, so that number's right smack in the middle. But this time they're giving us a percentile. So when they say the 84th percentile, what they're saying is the area to the left is 84%. So let me show you what that looks like. All right, so what you do is you draw your normal curve right smack in the middle. You got your mean, right? But you're drawing your area, and when you draw your area, you draw it so that it looks like 84% of that curve is shaded in, right? So this is about 0.84, and you don't know exactly where to stop. So you're kind of guessing, right? But you have an idea it's going to be somewhere around this area, right? So first you draw your normal curve here, and you shade all this area. So again, whenever they use that word percentile, you always start shading starting on the left-hand side. So make sure you write that down, or else you will forget it. All right. So this time we need a new program. So because they're asking us to find an X value and they give you an area, now we're going to use this program called inverse norm. All right. And notice what inverse norm is going to ask you for. The first thing it's going to want is the proportion. So write that down. It wants the area to the left. A lot of you guys have the calculators, the fancy calculators where you use inverse norm. It's going to say what's shaded, the left, the right, or the center. In some of your calculators, it's just going to be an empty, something basic like this. So the first thing we're going to enter is the area, the mean, and the standard deviation. So let's do it. So let's go to our calculator, and we're going to do second vars. We go to inverse norm, right? Because we're looking for the X value now. So we do 0.84. Our mean was, darn it, I forgot, 55. And our standard deviation, I believe, oops, I said 55, didn't I? And our standard deviation, I believe, is 9. So let's plug in that 9. And boom. So we get the X value that we're looking for. So this time we're looking for an X value. So 63.95. So let's go to our problem just to make sure I plugged in the right information. Looks like we did. There it is, 63.95. So the 84th percentile of the population, we're going to round that up to 64. All right. And then let's read the instructions real fast. Round your answer to at least 1 decimal place. All right. So since we got 95, this is 5 or more. So this will round up to the next 10th. All right. So that's why this turned to 64. All right. Let's do another problem. Number 3 here. Okay. So now for all you vegans out there, I went vegan for how long ago? I think it was for a couple hours. It was pretty good. So let's look at this. So vegan Thanksgiving. So we got tofurkey. Tofurkey is a vegan turkey substitute, usually made from tofu at a certain restaurant. The number of calories in a serving of this with wild mushroom stuffing and gravy is normally distributed with a mean of this and a standard deviation of this. And you might be wondering, like, what are they even talking about? Well, let me just paint a picture for you real fast. Let me make it maybe a little more relatable to some of you. So let's say that I go to Max Fit, and on their menu, they're saying, you know what, I'm checking my macros, and for this meal, I need, I don't know, let's say 80 grams of protein. Um, and so let's pretend I'm going to get a meal that in total has 80 grams of protein. So like it's really high in protein. But, right, they could have a whole stack of meals that are the same exact dish. But on all those meals, it's going to say, hey, they all have 80 grams of protein. But we know that's not true. They do their best, right? But everything isn't measured to perfection because we're humans. So some might have 80, some, I don't know, might have 75, some might have 85. Some might have 90, right? Because it might have other things besides the meat that has protein. Might have quinoa, might have, all these other good stuff in there. So again, the majority of those meals are going to be right here in the middle, but there's going to be some meals that have really high protein, very few of them, and there's going to be some meals of the same exact type that have very low protein. So that stack of all those meals that you guys see in the frozen food section, or all these places, or McDonald's, and they have like the fats, carbs, and proteins, right? They're all going to vary. Even though it's supposed to be the same, they're going to vary a little bit with the macros. So this is where we get this normal distribution, right? So I just wanted to paint that picture for you. All right. So here it says, what proportion of the servings have less than 539 calories? All right. So again, we're going to set this up the same exact way. So what we do is, let's go ahead and draw our curve. All right, so here, it's already drawn for us. So we got a normal curve, and just like I told you, right smack in the middle, you put the mean. So the average was 486 calories, right? That was the average, 486 calories. And then we're trying to see what proportions of the servings have less than 539 calories, 539 calories. So this right here would be our X value that we're after. All right, so this would represent our X value. So that is what we put over here. And make sure this is bigger, so I just put it to the right, okay? And then we shade everything to the left because it says the words less than. All right. So when you do this, make sure your answers make sense, because here it would not make any sense if my answer came back to be 0.13, because everything shaded here is greater than 50%, is greater than 0.5. So having 0.13 makes no sense at all, right? So again, use logic after you get these answers. Okay, so we have a normal curve, and I'm after the proportion. So what that tells me is that I have to use the program normal CDF. All right, so our mean is 486, and our standard deviation is 31. So help me out, remind me of that. All right, so 486, 31. So I'm going to do second vars normal CDF. I'm going to go to, I forgot already, 486. Oh, darn it. See all these kids in the background helping my son out. So my daughter and my nephew, they're distracting me back there. 486. So my lower bound, since I shaded to the left, I do negative 1 second E 99, comma, and then I do my upper bound. My upper bound is where I stop shading, and we said we stop shading at 539. So I put 539 for my upper bound. All right, my mean, we said the average was 486, 486, and we go all the way to, and then our standard deviation, excuse me, for this problem was our 31. Standard deviation was 31. All right, so hit enter, and boom, And so we could see that from the drawing, the majority of things were shaded. So about 0.9563, we're gonna round to 4 decimal places, all right? So that is our proportion. And so when I look at the answer here that's provided, 0.59563, just like we got. All right. So again, notice for number one, I wanted an area. All right, so let me go back down so you could copy that down. All right. So we could conclude that the proportion of servings that have less than 539 calories is this amount. So what does that mean? Well, that means, let's say I order 100 meals of these. Say I work at Nod Hill and I'm ordering these for Thanksgiving to sell. So I'm a manager at Nod Hill, just make it a situation here. And I order of 100 of meals just like this, right, to sell to at my store, right? So what I know is that 95.6% of those meals is going to have less than this amount of calories. How is that going to help me? Well, in that situation, I don't know, but I know if I'm a company, so there's this company called, it was a cookie company. They sell good cookies. Linny and Larry's. It's one of those protein cookie companies, right? So look it up. They were making a claim of how much protein was in each cookie. And so it turned out that their claim was not true because someone did an audit, right? Because they were claiming, hey, these cookies have this amount of protein. And I think it turned out to be less than half because someone actually did a study, found out. I'm not sure if they got sued or not, but again, so again, this stuff is used often. Let's say I am Martinelli's, which is a juice company, an apple juice company here in Watsonville, and they want their machines, right? They send juice all over the world, and they're saying, hey, on average, we're filling our juices with 12 ounces of Martinelli's juice, apple juice. But then they send it off to like Japan and stuff. And what they do is they might, pop a random sample open and they might say, you know what? This guy's juice is only about 9 ounces or something because maybe the calibration's off on the machines, right? So that might be a bad thing for business. So again, there's so many ways and things you could utilize this for. All right. So find the 75th percentile. So now they're changing the question on us for part B. So find the 75th percentile of the number of calories. All right. So here we got our mean. Our mean was 486. And now what we're going to do is we're going to shade everything to the left. And we keep shading. All right. We start from the left, excuse me. And you keep shading until you get to something that looks about 0.75. So notice this red line here is our halfway mark, is our 50% mark. So I have to keep shading, right? About 25% more, right? And so wherever that may be, that's what we're looking for, that X value. So that I know that everything to the left of this X value would represent 0.75. All right, so because I'm looking for an area, so always know what you're looking for. Whenever you're looking for a percentile, right, they're giving you the area. And when they give you the area, then here we're looking for this X value that corresponds to that area of 75%. All right, so we go ahead and we use inverse norm, just like we said earlier, and let's punch that in. So we go to inverse norm, so second distribution, inverse norm, the first thing they're going to want is the area of 0.75. All right, then they want the mean. The mean is 486. And then our standard deviation is of 31. All right, so let's punch all that in and we get 506.9. Right, so let's go back to our other screen. And so notice they punch all that in, boom, and they get the same answer, and they probably wanted us to round to the nearest hundredth, so that's why they did that. All right, cool. So this is how we're going to use the program's normal CDF and inverse norm, inv norm. Let me just go through these problems real fast to make sure nothing funny happens on these. I don't want you guys to be lost on your homework. Nope, it looks good. Notice for part B here. Let's look at this question real fast. It says, according to the government energy agency, the mean monthly household electricity bill in the United States was 108.87. So assume the amounts are normally distributed with the standard deviation of 18. All right, so notice they tell us it's normally distributed. So we're going to have a bell-shaped curve. The mean right smack in the middle is going to be 108.87. And our standard deviation is going to be 18. Well, for part B, they're giving you the lower and they're giving you the upper. All right. So that's the only thing that's different that I haven't done. So let me just fast forward here and let me just show you for part B. It's the same thing. You still want to draw your curve. Right smack in the middle is your mean. And then the two values here that are of interest are 83 and 145. So when you're using normal CDF, the only thing that's going to change is now you have your lower bound and your upper bound, right? And so notice down here, the program, that's what they have here. The 83 is where you start shading. The 145 is where you stop shading, all right? And it's the same exact process, right? And you get 0.923. All right, so again, I just didn't want you guys to feel confused on any of these. And let me look at the last one. So now for all these, they're doing percentiles. Look at for part C, they said find the median, right? So you might say, hey, Dr. Math, you didn't go over one where it says find the median. Well, if you remember from chapter 3, and if you're not in my class, it's from one of the early chapters. Whenever they're talking about the median, right? Since we have a normal distribution, that means everything's symmetric. The mean and the median are equal, all right? So whatever the mean is, that means the median is the same. So the median is the number right smack in the middle. And they tell us from the beginning that the number right smack in the middle is 108.22, all right? So that question is mainly meant so that you have a good understanding, all right, of what we're looking at. And the median is also known as 50% mark, right, in our data, which is right smack in the middle. And if we look at our curve right smack in the middle, is that 108.22. All right, so however you look at it, it means the same thing. All right, mathletes, hope this video was helpful. Make sure you like, subscribe, so that other students here at the college and other colleges and maybe high schools are able to use this and understand this stuff. All right, guys, have a wonderful day. I'll talk to you later. Peace out.